Hey, there we go. Okay. Whoever happens to be on, good morning. It is Monday morning, April 6th. Okay, so the plan is for today, the main topic is to go over pre-cal's lecture for the week. So we're going to learn our next set of identities we have for trig. For this week, we're just going to keep it to just simple computations. Oh, I actually need to update what's on the Google Classroom. So the file I posted for this that's on the Google Classroom right now is way out of date. So let me do this real quick. I'm going to make sure I save this. Yeah, because I remember last week somebody had requested to have the PowerPoint available ahead of time to write on. And I tried doing that, and I uploaded the one from 2 years ago. So you get to watch me edit things live. Here we go. Okay, so that should be a lot better. So for those of you that had the PowerPoint open ahead of time to be ready for the lecture, go ahead and refresh the page, open the one that's up now. Okay. I guess while we're on the classroom page, we can talk about a few things before we do the lecture. The main thing is for those of you that want to participate in the extra credit project, then you do have a checkpoint that is due this Wednesday. I'll post more about it on the Google Classroom. You do need to basically, I'll talk about it. I'll make a classwork post about it. But for those of you that are participating in the extra credit, I need to know your group names, or whoever's in your group, and you need to name your island by Wednesday. And for those of you that missed the Zoom meeting on Friday, a summary of it is down here. You can see the PDFs. You can watch a recap of the Zoom meeting if you would like. And I did put in all the extra credit for everyone that participated. Your grade should have been fixed. I finalized it last night. So for high school pre-cal kids, I just took your lowest homework grade, whether that was one of those numbers that all were the same, replaced one of them with 100, or if you happen to be missing something, I did whatever was the most beneficial to your grade. Dual credit people, I either replaced your lowest homework grade on my math lab, or if you already had a A/100 homework average, I added an extra 100. So.
You need more graph paper. Can you do that?
Not right now. Oh. My kids are having a hard time with they're asking a favor of me. So. Alright, so I guess while I am getting everything ready, I will just talk randomly while I'm doing this thing for my kid. Oh, this isn't working. Let's see. Okay, grades were, all your teachers finalized grades yesterday, so they were due for us last night at 10 p.m. So everyone's grade should have been accurate for me. I put in all your late work stuff. I keep getting the question, why are these 9 grades all the same? I think I've answered about 12 emails at this point about that. I did post earlier about it, but just in case I'll just keep talking about it again. The reason why is because when we started, officially going to online schooling, they changed the weights of all of the grades. So homeworks are now 80%, tests are now 20%. Which means that a homework, like a missing homework, if you had a missing homework, would negatively affect you way, way more than it had been before. Because before, homework was only 20% or 15%, depending on what class you're in. So what I decided to do, and they gave us several options for it, but I just took every grade that we had before spring break took what your average or progress report had been and put that grade in for everything. So that way, now a missing wouldn't matter because you wouldn't have a missing anymore because they all got filled in with something. I know that some people had papers turned into my classroom, my physical classroom. Some people had things turned in. I had no way of tracking that. So that's why I put that exam number 1 assignment right here. That exam number 1 assignment. And so, most of you that needed it did that, and then I fixed your grade. I changed all those 9 grades, whatever. I changed them to the appropriate average that you would have gotten if you made up test number 1 along with some of your missing homework. And then everything from now on with online should weigh correctly. So, please keep emailing if you have other questions, but that one's the one I got the most often. Okay. I cannot find... Okay, so the whole reason I'm stalling is because when I teach this lecture, my kids are also doing school, and they ran out of graph paper, and they have this specific one that they want me to find and print for them, but I cannot find it. Oh, you know what? I think I just found it. There it is. Printable graph paper. There we go. Yeah, Asher uses graph paper to do some of his math for school. He's really been into math lately, so. Alright, let's print this. There we go, it started. Alright, sorry, I'll actually start teaching now. Okay, so again, if you had this open, you can ignore this 7-3 thing. There we go. So we are going to learn sum and difference identities today. So I'll tell you a little bit about why we use it, how we use it, and it's going to refer to your unit circle a lot. So if you want to pull open a PDF or whatever paper copy you have of your unit circle, that would assist you a lot today. So there's mine. There we go. Okay. There we go. So the problems that you're going to be doing in this section, I'm sure y'all can probably just hear my printer going, huh? Oh, no, you can't. Okay, cool. You need to be able to look up exact values of things off your unit circle, exactly like we did before. And you notice how we keep doing this, looking at unit circle stuff over and over again. That's why we have formula charts and everything for this test. So what is the sine of 30 degrees? I know it's been a very long time since you've answered that question, but you head over to 30 degrees. Let me use my mouse cursor. So 30 degrees right here. And then remember, sine is always the y coordinate, cosine is always the x coordinate. So sine of 30 degrees is 1/2. So, all right, 1/2. Cosine of 210, head over to 210. And then you want to do the x coordinate, which is negative square root of 3/2. And then tangent of 60 degrees. And tangent requires a little bit of work because once you get to 60, then you want to do y divided by x, just like your formula chart back here said, right? Right there. So tangent of 60 degrees is y divided by x, so square root of 3/2 divided by 1/2. And just like always, tangent is the most annoying one because you always deal with fractions inside of fractions here. So keep the first one, flip the second one, and multiply. And notice how those 2's cancel out. So the answer is square root of 3. There we go. And this is all stuff you've done before, right? You had to do all this whenever you did test number 1. Yeah, test number 1. Oh, by the way, we are only going to, assuming this goes till the end of the 6 weeks, so, well, I mean the end of the school year, you're only going to have 2 tests. Remember, also, tests are only 20% of your average, but they're going to be whenever I actually delve into your work and grade every single problem. I know it seems backwards, but they really want participation to be the thing that influences your grade the most, which is a little silly, but I understand why they're doing it. You've got kids, you've got kids struggling to get online just to do their work. You've got people with siblings at home and they all have to share the same computer, that kind of thing. That school iPad might literally be the only technology some people have at home. So you got to give them a little grace. And we're not here to fail people. I mean, I don't know. Hopefully we're not. There are some people that try to find any excuse they can to fail kids. I'm not one of those. Okay, so here are all the sum and difference identities. So homework last week, you talked about all of those trig identities, how you can do substitutions for different expressions and prove things are equal to other things. We're going to be doing more of just plugging in direct numbers today. And keep referring to this slide. I'm going to keep flipping back to it. You'll see why we use it. We're going to plug in numbers for A and B and look up a bunch of stuff on our unit circle to try to figure out some of these problems. So why do we need these? What is the whole point of these? Well, the reason you take something like sine of A plus B and then you expand it into all these things is because sometimes you're asked a question where you can't currently get the exact answer. What is the cosine of 75 degrees? Well, if you look at our problem, if you look at our circle, 75 is not here, right? There is no 75 degrees. So what do you do to handle that, right? Well, great, why don't we just type it into the calculator? Always your go-to thing, right? I mean, you can. But it's not like your calculator can give you a square root answer, right? We don't have the computer algebra system calculators here. So math enter doesn't work here. It's some decimal, and you can't give me the decimal because we know the decimal goes forever, and that's not an exact answer. So if I ask you for the exact answer of cosine of 75, which is what this is asking, right, you can't just give me a decimal. If you give me a decimal, you get 0 credit for this, even if it's that off the calculator. Please don't give me decimals on here. Okay. So what we need to do is rewrite the number 75 as a combination of some things off of my unit circle. So I don't have 75 on my unit circle, but the whole point of today is, can I find two numbers on my unit circle that either add or subtract to give me 75? And the cool thing about these problems is that there are going to be multiple correct answers to this question. Because for some of you that are listening right now, cosine of 75, well, for 75, one of the easiest ways is 30 plus 45, right? 30 plus 45 gives you 75. But you have other options. You have 120 minus 45, right? And you've got that same gap everywhere else, right? 315 minus 240, etc., etc. So you've got multiple places where you can get 75. See, 210 minus 135. So there are tons and tons of ways to get two things that add or subtract to give me 75. So the main question people have at the beginning of this unit is, which one do I use? The answer is, you know what? For sine and cosine, who cares? It doesn't matter. They're all going to give you the same correct answer. Okay. For tangent, it's a different story. I'll explain when we get there. Okay, so cosine 75. Let's do the easy one, which is what I normally guide people to do. Cosine of 45 plus 30. So I'm going to rewrite the number 75 as 45 plus 30. And then we are going to use this formula right here. So we can't look up cosine 75 on the unit circle, but we can rewrite it as a bunch of cosine 45s and 30s and sine 45s and 30s if we use this formula. So let's head back. Let's head back here and rewrite this as cosine of 45, cosine of 30, minus sine of 45, sine of 30. And now I've solved the problem of, I can't look up cosine 75, But I can look up cosine 45. I can look up cosine 30, sine 45, sine 30. I've changed this problem into 4 things I can directly look up off the unit circle. So I head over to 45 and 30, pull off the appropriate numbers, and when you do your math, you get square root of 2 over 2 times square root of 3 over 2 minus square root of 2 over 2 times 1/2. And then you get square root of 6 over 4 minus square root of 2 over 4. And you are subtracting 2 fractions. They already have a common denominator. And in fact, hold on, let me do this. They'll always have a common denominator, because if you look at all these fractions, we're just looking up a bunch of crap on the unit circle, and they all are divided by 2. So you're going to end up with a divide by 4 for all of these. So square root of 6 minus square root of 2. Remember, you can't subtract square roots, so leave it like that. Divided by 4. There you go. So the exact answer is square root of 6 minus square root of 2 all over 4. And if you double check yourself, there you go. Decimals match. That is the answer. So that's all there is to it. So just come up with 2 numbers that add or subtract to the given part of the problem. Then you use the appropriate formula off of this page. And then look up, usually ends up looking up 4 things off the unit circle. And it's going to be some combination of 1/2 square root of 2 over 2 or square root of 3 over 2 every single time. So your answers are all going to look really, really, really similar to each other, because there are not that many different numbers to use. The only thing that changes are the negatives or the positives in front of square root of 6 or square root of 2. The only things that change. So just get some practice on this, and probably when we do more stuff next week, we're going to incorporate this into proof problems that we've been doing last week. All right. Sine of 195, let's do this next. So 195, again, 2 numbers that add or subtract to give me 195. Wait, it was 195, right? Yeah, so we could do, so lots of options here, right? 135 plus 60, 150 plus 45, 225 minus 30. You decide. They are all going to give you the same answer. So I will pick, let's see, 220. Let's subtract something in this problem. So we'll do, 225 minus 30. So that formula, and you look back here. Pause for a second for those of you. Okay. Sine 225 cosine of 30 minus cosine of 225 sine of 30. Hold on 1 second, let me get this. I hear my kids whining. Hey, Molly? 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 All right. Graph paper drop off. Successful. Okay. So head to your unit circle, look up 225 and 30. So 225 is down here on the bottom left, are both negative square root of 2 over 2. And then we know 30 because we use it all the time. So negative square root of 2 over 2, square root of 3 over 2. And see how these numbers are already getting pretty repetitive. So if you look on the right part of this, you've got a double negative. So be careful with your signs here. We have negative square root of 6 over 4 plus square root of 2 over 4. And if you want, when you're doing this work, you can skip this part. We know it's going to have a common denominator. You could have immediately just gone to negative square root of 6 plus 2, square root of 2 over 4. You can just hop straight from looking up unit circle to there if you want. And I realize it's behind my face on the webcam. But there you go. Whee! All right. It'll be okay on the PowerPoint. Okay, let's do a tangent problem. Tangent, as you saw earlier, is going to be the most annoying one because you have to deal with fractions. The formula itself is a fraction, so you're going to have fractions inside of your fraction. Now, what we just talked about here, there's tons of ways to get 75 or 195 or whatever the problem is going to ask you, right? There are lots and lots of different ways to add or subtract things to get your number. For sine and cosine, it doesn't matter what you pick because all it does is change the order of square root of 6 and square root of 2. Nothing else changes. With tangent, it does change what ends up getting plugged into the problem. So before we start the problem, I'm going to do a little bit of a quick exercise with you. I'm just going to find the tangent of those first three, 30, 45, and 60. Okay. Actually, we'll just do 0 to 90. So let's just do quadrant 1 tangent real quick. It's going to save us some time later. So I'm going to just stick it in the top right corner. I'm going to write under my overlay on purpose. So theta. What is tangent of theta? Whoa. Whoops. Okay, I don't care. Clear. Go away. Okay. So 0, 30, 45, 60, and 90. Okay, so the tangent of 0 is 0. Tangent of 30 is, and then you can refer back to what we did back here for all these answers, but I'm going to save us a little time. Tangent of 30 is square root of 3 over 3. Tangent of 45 is 1. Tangent of 60 is just square root of 3. And tangent of 90 is undefined. You're going to be using these numbers over and over and over again, so just have those handy. Okay, so find the tangent of 15. Now, we head over here, and the first instinct for a lot of students when they first do a tangent problem is for something like 15 or whatever the numbers may be. You're thinking, oh, wait a minute, 45 minus 30. That is a really easy way to get to 15. The only problem with doing that is that 30 degrees ends up giving you square root of 3 over 3, which is fine, but whenever you look at this formula, you end up putting a square root of 3 over 3 in the top and bottom of a fraction. So you end up with a fraction and a fraction, so two things happen. One, you need a common denominator on the bottom, and then you have to do keep flip change, along with just doing keep flip change to find tangent in the first place. So it ends up being a long problem. My recommendation for this is as you look up things for 15 or for whatever your problem is in tangent only, try to avoid using 30 or anything that has a reference of 30. So 150, 210, or 330. It will save you a lot of time. You can ask any of my dual credit students why we tend to avoid using those if you have any questions about why. It makes the work over twice as long. So I'll tell you that. So instead for tangent of 15, I'm going to use 60 minus 45. Okay, still works. And then you can use lots of, you could have done 135 minus 120 or 240 minus 225. So anything that avoids 30, 150, 210, or 330. Okay. So I'm going to rewrite this as tangent 60 minus 45. I guess I should put little degrees there. Okay. So now whenever I do the tangent subtraction formula right here, you end up with tangent of 60 minus tangent of 45 all over 1 plus tangent of 60 times tangent 45. Now there's actually good news to come out of this. We only have to look up two things because tangent 60 gets repeated, tangent 45 gets repeated. I already have those handy over here to the right. If you didn't know these already, you would have had to look them up and calculate them every single time. You can skip that on my work if you're turning it in for homework. So this ends up just being square root of 3 minus 1 all over 1 plus square root of 3 times 1. Which times 1 doesn't do anything, right? So who cares about that? Now the only issue with this is that we have a square root in the bottom of a fraction, which you know you can't do. Okay, so we've got to the trick here we use, and we've used it for fraction problems in the past, is to multiply by the conjugate. So 1 plus square root of 3, the conjugate will be 1 minus square root of 3. Just change the sign in the middle of the thing. But you can't change the answer, so I have to do it to the top and bottom. I just want to multiply this by quote-unquote the number 1. So I'm not changing the actual value of the problem, but I will end up getting rid of the square root on the bottom because that's what conjugates do. So let's FOIL the top and bottom. I end up with square root of 3 minus 3, because when I do that outside multiply, square root of 3 times square root of 3 just ends up being 3. Minus 1 plus square root of 3. Then on the bottom, of course, we picked the conjugate because these square roots are going to end up adding up to 0. So combining like terms, we have 2 square root of 3's minus 4 divided by negative 2. And then you can just distribute that negative 2 to both of these. So you end up with negative square root of 3 plus 2. And trust me when I say, if you had picked 45 minus 30, this would have been a much, much longer problem. Okay. Yeah, I mean, that's it. So that should get you through your homework. Pre-AP, stick around because we are going to do radians next. But regular, that's pretty much all you need to know. That covers your whole worksheet. And I guess we'll go to the last slide now. So, pre-AP. So you get to do radians for half of your homework. So it's the same exact work, right? The middle of the problem is exactly the same, except 5 pi over 12, so you need to come up with 2 radians that add or subtract to 5 pi over 12. And again, it's a tangent problem. We're trying to avoid, pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6 as much as we can. My tip, because I know a lot of you just really hate fractions, and most students do, but for 5 pi over 12, if you look at all of the radians, all of these fractions, the least common denominator for everything on the unit circle is 12. So if you want to just mentally or actually on your unit circle, just think of all of them in reference to 12 in the denominator, it helps you a lot. So 30 degrees ends up being 2 pi over 12, 45 degrees ends up being 3 pi over 12, 4 pi over 12, 6 pi over 12, 8 pi over 12, 9 pi over 12, 10 pi over 12. So you start to see the pattern there. Okay, so this is mostly pre-AP only, so regular doesn't have to worry about this. I'm going to try to do a, let's see. Oh, I guess the other way too. Okay, so you got 2 options here. The other thing you can do is just convert the radians into degrees, and then just do the problem in degrees. So remember to convert radians to degrees. 180 over pi. Pi's cancel out, so you just have to do 5 times 180 divided by 12. Yeah, I guess that's easier for y'all. I've had teachers in the past not let me do that, or like at least not show that work. I mean, it's actually 75 degrees, but So let's pretend we're doing everything with fractions in our head, but we know we're just doing 75 in our head. Okay. Now if we look at our unit circle, if we do pi over 4 plus pi over 6, you end up getting 5 pi over 12. 45 plus 30 is 75. Another way to think of it that way. So I just told you to avoid using 30, 50, 150, 210, 330. Because this is a pre-AP slide, I'll show you why. So why avoid 30 degrees? You know, also pi over 6. So why not just show you now? Because it's a pre-AP slide. So this is tangent of, and then we're going to do pi over 4 plus pi over 6, or 3 pi over 12 plus 2 pi over 12. Or convert to degrees and just make it a degree problem, right? Adding an extra step of work. So formula says tangent, and again, the whole reason I'm doing this is because just to show you how much more annoying this problem is when you use 30. Okay. And then so tangent pi over 4 is the same thing as tangent of 45, which is 1. Tangent of 30 is square root of 3 over 3. So you end up with 1 plus square root of 3 over 3 over 1 minus square root of 3 over 3. So not only do you have to get rid of the square root on the bottom, you've got to get rid of the 3's by doing common denominators for everything. So that's why this is a way worse problem. You've got to do common denominator. Oh, whoops. There we go. I can't write the 3. It's right under that little pen graphic. Okay, there we go. Okay, so we've got to rewrite the problem as 3 plus square root of 3 over 3 over 3 minus square root of 3 over 3. Then you have to keep flip change. Oh wait, 3 plus square root of 3. Hold on, this is way too sloppy. All right, 3 plus square root of 3 over 3. We're going to keep flip change. 3 over 3 minus square root of 3. 3's cancel. And then finally, after 2 lines of work, I've gotten back to where I was at the beginning of this problem. So you have 3 plus square root of 3 over 3 minus square root of 3. Remember, nothing cancels here because of the plus and minus. So now you've got to do the conjugate of the denominator. You end up with 9 plus, oh, I do not have room for this. Hold on. I'm just going to write under my overlay again because, oh, you know what I really should be doing is, okay, for the sake of people that are going to look at this at home, we're going to start the work way up here. You're welcome, YouTube. Okay. There we are. So we've got to FOIL the top, FOIL the bottom, and the whole reason we pick this, the square roots will go away in the denominator. So we have 9 plus 3 root 3 plus 3 root 3 plus 3, all divided by 3, plus 3 root 3 minus 3 root 3 minus 3. And those add up to 0. No more square roots on the bottom. You have, and then I'm writing under my face again, 12 plus 6 square root of 3. Oh, this should be a 9 in the front. What did I do then? Let's say it shouldn't be 0 on the bottom, right? Okay. So the numerator is 12 plus 6 square root of 3. The denominator is just 6, and then that 6 distributes to both 2 plus square root of 3. So all of that work just to get 2 plus square root of 3. You could have completely avoided, here, let me get my little mouse cursor, where is it? I can't find my mouse. There it is. You could have completely avoided all of this or this here, those 3 lines of work, if you had just used another combination for 75, right? 120 minus 45. 2 pi over 3 minus pi over 4, however you want to think about it. Okay. All right, that is our lesson for today. Okay, so let me know if you have any questions, either in chat or through email, or come to office hours on Wednesday, or ask during office hours tomorrow. So tomorrow is going to be dual credits lecture. For those of you doing the extra credit project, you are going to have something due Wednesday this week. But this homework, this one, the sum and difference ones, is due on Friday. So I think for high school pre-cal, this is going to be your pace for the rest of the year. We'll have a lesson on... Y'all hear my kids back there? Lesson on Monday to be due on Friday is going to be our standard pace, I think. And then anytime we're ready for a test, we'll be sure to incorporate that somewhere in the middle of the week with a test review or something. I'll just have question and answers up here. Oh, we could do something like a Twitch Plays Super Mario Party for a test review game. Oh, we should do something like that. That would be fun. Okay, so that's all I got for today. See you later.